Okay, good morning, students. This is MC sir. Today we have to discuss our concept is measurement. Already we discussed some points in this concept: quantity, physical physical quantity, and system of physical quantity. System of physical quantity. How many system of physical quantities are there? There are three system of physical quantities. There are three system of physical quantities. First one, fundamental physical quantity. Second one, derived physical quantity. Third one, supplementary physical quantity. How many system of physical quantities are there? Three system of physical quantities. Okay, first one, fundamental physical quantity. Second one, derived physical quantity. Third one, supplementary physical quantity. This point already we discussed in the last class. So one time we have to recall that points. Okay, what is fundamental physical quantity? What is a fundamental physical quantity? Okay, these quantities are base quantities for entire our physics. Okay, entire our physics formulas, entire our physics physical quantities. Okay, which one is the base one means? So fundamental quantities. Okay, how many fundamental physical quantities are there? There are seven fundamental physical quantities. How many? Seven fundamental physical quantities. What are they? First one, length. Second one, mass. Third one, time. Fourth one, electric current. Fifth one, amount of substance. And sixth one, luminous intensity. Okay, so another one, seventh one, thermodynamic temperature. Thermodynamic temperature. These all are fundamental physical quantities. These all are fundamental physical quantities. Fundamental physical quantities not depending on any other physical quantities. Not depending on any other physical quantities. Okay, students, these quantities are fundamental physical quantities. But what about derived physical quantity? What about derived physical quantity? Now we want to discussing about that derived physical quantity. Okay, so now just identify that point, derived physical quantity. Derived means these quantities are derived from fundamental physical quantities. Just to we have to identify this point. These quantities, which quantities? Some physical quantities. Some physical quantities are derived from fundamental physical quantities, are called as derived physical quantities. How many number of derived physical quantities are there means n number of physical quantities. What are they? What are they means we don't know, but some physical quantity we want to learn from 6th to 10th class. From 6th to 10th class, we have to learn some physical quantities. What are that physical quantity? First, we have to identify. So here, first one, area. First one, area. Okay, it's very, very important physical quantity. Okay, so first one, area. Area is one derived physical quantity. Second one, volume. Second one, volume. Third one, density. Third one, density. Fourth one, pressure. Okay, fourth one, pressure. And fifth one, so speed. Fifth one, speed. Next one, sixth one, velocity. Velocity. Okay, next seventh one, acceleration. Acceleration. Okay, next eighth one. Eighth one, force. Eighth one, force. Next one, ninth one, work. Ninth one, work. 10th one, power. 10th one, power. 11th one, energy. Energy. The next one, 12th one, momentum. Momentum. Next one, 13th one, so impulse. Impulse. Okay, etc. etc. Okay, enough. These quantities are enough from 6th class to 10th class. So these points we have to learn repeatedly in 8th class, 9th class, and 10th class. Because of that reason, we learn these derived physical quantity. Okay, are you identify this point? So no need to learn all physical quantities, then we can get the confusion. Okay, students. So first we have to learn this physical quantity. How many physical quantities? How many system of physical quantities are there? Means three system of physical quantities. First one is fundamental physical quantity. Second one, derived physical quantity. Okay, in derived physical quantities, we have to consider some examples. What are the examples? First one, area. Second one, volume. Third one, density, pressure. Next, so speed, velocity, acceleration, force, work, power, energy, momentum, impulse. These all are examples for derived physical quantity. Okay, students. Next one, we want to identify that formula for derived physical quantity. Formula for derived physical quantity. These all are fundamental formulas for that particular physical quantities. What is that? Fundamental formulas for that particular derived physical quantities. So we have to identify area. What is that? Physical quantity, area. Okay, what is the fundamental formula of area? Different areas are there. Area of circle, area of cylinder, area of a sphere. Okay, different areas are there, but only we have to learn fundamental formulas. So fundamental formula of area, length into breadth. Length into breadth. Very important. Okay, so it is the fundamental formula for area, basic formula. So after that, we have to derive different formulas. Okay, students, so now we can consider this point. And next one, volume. Volume formula of volume, length into breadth into height. Length into breadth into height. We can identify this point. Next one, density. Next one, density. Density means mass per unit volume. Mass per unit volume. Okay, we have to write M by V. Here M represents mass, V represents volume. Next one, pressure. Next one, pressure. Formula for pressure. Force acting per unit surface area. Okay, here consider that surface area, how much? 1 unit surface area. Force acting per unit surface area. Next one, speed. Speed equal to distance divided by time. Distance divided by time. Okay, next one, velocity. Velocity equal to displacement divided by time. First, we have to note down these formulas. Do you have any confusion? Do you have any confusion? So maybe you are getting the confusion with the symbols. With the symbols. So we have to write that formula. Length into breadth. Okay, length into breadth. Next one, length into breadth into height. Okay, next one, mass per unit volume. Okay, next one, pressure. Pressure equal to force acting per unit surface area. So we have to represent force per unit surface area. Per the unit surface area. Force acting per unit surface area. Next one, distance divided by time. Distance divided by time. Next one, displacement. Displacement divided by time. Okay, students, it is symbolic representation for that particular formula. So generally we have to explain that formula with a sentence. Okay, area equal to length into breadth, volume equal to length into breadth into height. So here density equal to mass per unit volume, pressure equal to force acting per unit surface area. Next one, speed equal to distance by time, velocity equal to displacement by time. Note down this formulas. Next you can continue remaining the formulas. Okay, students, now just observe here. Area equal to length into breadth. How to derive this physical quantity from fundamental physical quantities? How to derive these physical quantities from fundamental physical quantity? We have to identify this logical point. Here, area equal to length into breadth. Just we have to imagine that figure. Okay, it is one rectangle. It is one rectangle. Okay, length of rectangle A, B, C, D. We have to identify length of rectangle is L. Breadth of rectangle is BC. Breadth of rectangle is BC. Now just identify here L. L means length. Length is one fundamental physical quantity. Yes or no? Next, we can identify that BC. BC represent in this rectangle is breadth. Yes or no? Identify this point. The breadth is also length. Breadth is also length only. So because of that reason, your area derived from fundamental physical quantities. So how many fundamental physical quantities used in this formula? Two fundamental physical quantities. Understood? Your area derived from fundamental physical quantities. Understood, student? Okay, this point is very, very important point. Derived physical quantities means that physical quantities derived from fundamental physical quantities. What are the fundamental physical quantities? Seven fundamental physical quantities. With the help of that seven fundamental physical quantities, we have to explain these derived physical quantities. Understood? Okay, the next one. Volume you have to consider. Volume means volume of cuboid. Volume of cuboid. Here just identify this diagram. Okay, volume of cuboid we have to consider. Okay, so we can find out that length, breadth, and height. Okay, length of cuboid L. Next one, breadth of cuboid B, height of cuboid small h. Okay, students, we can identify this point: length, breadth, height. length, breadth, height. Okay, volume of cuboid. So length into breadth into height. It is a fundamental formula of volume. Fundamental formula of volume. Don't forget. So here derived physical quantity. So example, volume equal length into breadth into height. This formula is derived from fundamental physical quantity. Height is also measured in meters. It is also measured in meters because it is fundamental physical quantity. Breadth can also measured in meters. Then it is also one fundamental physical quantity. Okay, length, breadth, and height. Okay, are represented fundamental physical quantities. This volume is derived from fundamental physical quantity. Length into breadth into height. Next one, density. Density equal to mass per unit volume. Mass is a fundamental physical quantity. Volume derived from fundamental physical quantity. Yes or no? Finally, density is one derived physical quantity. Density one derived physical quantity. So have to identify this point. Okay, students. Next one. Pressure equal to force acting per unit surface area. Pressure equal to force acting per unit surface area. Force derived from fundamental physical quantity. Area derived from a fundamental physical quantity. Understood? Because pressure is one derived physical quantity. Next, speed equal to distance divided by time. Speed equal to distance divided by time. Distance is nothing but length. Total length covered by an object is called as a distance. So we have to consider this path. So here consider that path is curved path. It is not a straight line. Total length covered by an object is called as distance. Here we can calculate that length in meters or centimeters. Yes or no? So distance is nothing but length. Distance is nothing but length because so we have to consider distance is a fundamental physical quantity. Don't forget this point. Okay, here speed derived from fundamental physical quantities. One is length, another one time. Okay, students, next velocity. Velocity equal to displacement divided by time. Okay, displacement means the shortest distance between initial point to final point. So in this condition, initial point A, final point to B, we have to consider that direction. We have to consider that direction in specified direction. Yes or no? Which is initial point? Initial point A, final point B. Understood, student? Here, consider that specified direction from A to B. So we have to define that displacement shortest distance between initial point to final point in specified direction is called as a displacement. It's called as displacement. Displacement divided by time. Displacement is nothing but length only. Okay, we have to calculate this displacement maybe 2 meters. Okay, understood this point? So here measuring that displacement is 2 meters. So here velocity equal to displacement divided by time. Velocity equal to displacement divided by time. Here also velocity we can explaining with the help of fundamental physical quantities. Because of that reason, these quantities are derived physical quantities. These quantities are derived physical quantities. Derived physical quantities means these quantities are derived from fundamental physical quantities. Understood, students? Next, we have to discussing about that remaining physical quantities. Okay, note down these points. Remaining formulas we have to note down. acceleration, acceleration equal to V2 minus V1 divided by time. Formula for acceleration V2 minus V1 divided by time. V2 represents the final velocity, V1 represents the initial velocity divided by time. Okay, next. So these points are very important. We can learn that. Formulas. What are the general formulas we have to discuss from 6th to 10th? That formulas we can learn. First, after that, we can learn that what is acceleration, what is speed, what is velocity, what is density, what is the force. So we have to learn in that points. Okay, students. So what is the necessities? What is the necessity? For example, in a first class. In first class, we can learn ABCs. Yes, sir. How many letters are there total? 26 letters. 27 or 26? Okay, so here A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. 26 letters are there. I can ask that meaning of each letter. Tell me what is the meaning of each letter? What is the meaning of each letter? A, B, C, D. Okay, these all are letters one. But why initially we have to learn this alpha ABCDs? Tell me. So 26 letters initially we have to learn without meaning. We have to learn without meaning. After that, we have to frame that word. We have to frame that sentence. We have to learn that spellings. Yes or no? So basics is very important. Okay, first we have to learn these formulas. After that, we can learn that each physical quantity, then we can identify. Okay, these are not formulas. These all are basics formulas. Okay, students, first we have to note down these formulas. After that, we can learn in our chapters, in physics chapters, these physical quantities. Okay, that is the importance. That is the importance of this formula in the first chapter. In measurement, we have to learn these formulas, units, and definitions. Units and definitions. Okay, students, just okay, note down these formulas first. Acceleration equal to V2 minus V1 divided by time. Next one, force. Force equal to mass into acceleration. Mass into acceleration. The next one, I have to note down momentum, linear momentum. Linear momentum equal to P equal to mass into velocity. Here also F. Here we have to represent acceleration A. Next one, impulse. Impulse J equal to force into time. Force into time. The next one, work. Next one, work. Work equal to force into displacement. Work equal to force into displacement. Next one, power. Power equal to work done divided by time. Work done divided by time. Work done divided by time. The next, energy. Energy, there are two types. Energy, there are two types. Okay, in mechanics, generally we have to consider two types of energy. One is potential energy, another one is mechanical energy. Okay, so we have to use two types of energy. Potential energy, another one is kinetic energy. Another one, kinetic energy. Note down these formulas. Next, we have to explain this derived physical quantity with the help of fundamental units. The help of fundamental units. Okay, so first one, note down this. So formulas. Formula for potential energy. Formula for potential energy, mgh. Formula for potential energy, mgh. Formula for kinetic energy, half mv square. Half mv square. Note down. Okay, now we want to discussing about that derived units. Derived units means the units of derived physical quantities. The units of derived physical quantities is called as derived units. Now we want to discuss about that derived units. Okay, students, note down these points, very, very important. Derived units. Okay, what are the derived physical quantities we discussed in before? First one, area. First one, area. Okay, identify this point. Area. What is the fundamental formula of area? Area equal to length into breadth. Length into breadth. Okay, what is the SI unit of length? Meter. 1 meter into SI unit of breadth? 1 meter. 1 meter into 1 meter. 1 meter into 1 meter equal to 1 meter square. Here, 1 meter square is derived unit of area. Derived unit of area. This derived unit we can expand with fundamental units. Understood? Derived units derived from fundamental units. We have it out. Okay. So here 1 meter is the fundamental unit of length. Here 1 meter is also fundamental unit of length. Here derived unit derived from fundamental units. 1 meter into 1 meter equal to 1 meter square. 1 meter square is the derived unit of area. Area is one derived physical quantity. Okay, next, one more physical quantity. Okay, second physical quantity, volume. Length into breadth into height. So here SI unit of length 1 meter. Okay, SI unit of breadth 1 meter. SI unit of height 1 meter. Okay, here how many times use these fundamental units? 3 times. Then we have to write this multiplication of these 3 fundamental physical quantity. Okay, 1 into m power 3. Here meter cube. Meter cube is one derived unit of volume. one derived unit of volume. That volume is one derived physical quantity. Understood, students? Okay, next one, density. Next one, density. Density equal to mass per unit volume. Okay, so mass, SI unit of mass. SI unit of mass 1 kilogram. SI unit of mass 1 kilogram. Symbolic representation of kilogram is 1 kg. Okay, so 1 kg per volume. Here derived unit of volume how much? Meter cube. 1 kg meter cube. Here fundamental units used 2 times. Kg is one fundamental unit of physical quantity. Yes or no? It is one fundamental unit of physical quantity. Which physical quantity? Mass. Mass is one fundamental physical quantity. So SI unit of mass 1 kg. Here SI unit of length meter, but meter used how many times? 3 times used this condition. Okay, understood. Here multiple times used that fundamental units in this formula. 1 kg per meter cube is one derived unit of density. Understood? Okay, students. Okay, 1 kg per meter cube is one derived unit. Next one, we can discuss one more physical quantity, pressure. Pressure before we can discuss a speed. Speed equal to distance divided by time. Distance divided by time. Okay, here SI unit of distance. SI unit of distance 1 meter. SI unit of distance 1 meter. Symbol for meter small m. 1 m divided by SI unit of time second. Symbol for second small. 1 meter per second is one derived unit of speed only. Derived unit of speed. I have to identify this point. Next one, velocity. Velocity equal to displacement divided by time. Displacement divided by time. SI unit of displacement. SI unit of displacement. Meter. Displacement is nothing but length. SI unit of length, meter. 1 meter per second. 1 meter per second. It is one derived unit of velocity. Understood? Okay, SI unit of velocity is 1 meter per second. The next one, acceleration. Acceleration equal to change in velocity. So we have to write change in velocity. Change in velocity divided by, okay, change in time or time you have to write. Time. Change in velocity divided by time. Okay, so change in velocity or unit of velocity is same. Okay, for example, I can give that condition for you, addition and subtraction condition. 1 meter per second minus 2 meter per second. 4 meter per second minus 2 meter per second. How much? 4 minus 2 equal to 2. Numerical value changes, but unit is constant. 4 minus 2, 2 meter per second. Here, numerical value changes, but unit is same. Yes or no? We cannot cancel that unit. 4 meter per second minus 2 meter per second equal to 2 meter per second. Because of that reason, change in velocity unit is also meter per second. Okay, so meter per second, 1 meter per second divided by second. 1 meter per second divided by second equal to 1 meter per second square. 1 meter per second square. Just identify these derived physical quantities and derived units. Okay, next we can discussing another so derived physical quantity units. Okay, note down first. Okay, students, let us continue our class. First. Next, we can continue our next derived physical quantity unit. What is that? Next derived physical quantity acceleration. After we have to discuss force. Force is denoted by the symbol F. F is equal to mass into acceleration. Mass into acceleration. Okay, mass into acceleration. SI unit of mass. SI unit of mass kg. SI unit of mass kg. Okay, SI unit of acceleration meter per second square. 1 kg meter per second square is the derived unit of force. The derived unit of force. Generally, this force explained by Newton. The honor of scientists we can given the unit for force is 1 Newton. Okay, here, so we have to consider 1 kg meter per second square. 1 kg meter per second square equal to 1 Newton. Okay, equal to 1 Newton is a very, very important point. Okay, so you identify this point. 1 Newton is the scientist name. Okay, the respect of our scientist have to give 1 Newton this unit. 1 kg meter per second square equal to 1 Newton. Who explain this force? First, Newton explained. Okay, because of that reason, we consider that unit of force is 1 Newton. 1 Newton equal to 1 kg meter per second square. Don't forget this point. Next one, we have to discuss about that pressure. Pressure is denoted by the letter P. P equal to force acting per unit surface area. Unit area. Very, very important. Force acting per unit surface area. What is the derived unit of pressure? Derived unit we have to represent 1 kg meter per second square divided by unit of area meter square. Yes, meter square. Understood? 1 kg meter per second square divided by meter square. So here meter power 2. We have to simplify this unit. 1 kg. 1 kg meter per second square divided by meter square. We have to write meter into meter. 1 meter cancel in numerator and denominator. Next we have to write 1 kg Okay, meter, we have to write this condition very important. 1 by A equal to A power minus 1. 1 by A equal to A power minus 1. Here meter consider in a denominator. 1 by M, we have to write M power minus 1. So write this condition kg meter power minus 1 per second square. Okay, per second square, or we have to write second power minus 2. Second power minus 2. Understood, students? Do you have any doubt? What is the SI unit of pressure? kg. Meter power minus 1. Second power minus 2. But directly we have to explain this unit of pressure. How? With the help of a scientist name. SI unit of force is Newton. So right here, SI unit of area meter square. So kg meter power minus kg meter power minus 1 into second power minus 2, you can write 1 Newton per meter square. 1 Newton per meter square. Understood, students, this point? Okay, so just to note down this point, very important point. Pressure equal to force acting per unit surface area. Derived unit of pressure. Derived unit of pressure kg meter power minus 1 second power minus 2. Okay, this derived unit we have to express in another way. So what is that another way? 1 Newton per meter square. Okay, students, note down this point. Okay, so after that I can explain this condition. So finally, we have to write this point 1 kg meter power minus 1 second power minus 2 equal to 1 Newton per meter square. 1 Newton per meter square. This is a very, very important point. Okay, so next one, another derived physical quantity is linear momentum. Linear momentum. Linear momentum generally denoted by the letter capital P. Denoted by the letter capital P. Capital P equal to mass into velocity. Mass into velocity. Okay, so SI unit of mass. SI unit of mass kg. So don't forget SI unit of mass kg. SI unit of velocity 1 meter per second square. 1 meter per second square. 1 kg, sorry Nana, 1 kg meter per second. 1 kg meter per second is the SI unit of linear momentum, or 1 kg meter per second is one derived unit of linear momentum. Okay, are you identify this point? Derived units means that units derived from fundamental units. That unit is derived from fundamental units. Here kg is fundamental unit, meter is fundamental unit, second is also one fundamental unit. Then we have to derive this derived unit of linear momentum with the help of fundamental units, kg meter per second. Understood, students? Note down this condition. 1 kg meter per second is the derived unit of linear momentum. Next one, impulse. Impulse or change in momentum. We have to write that change in momentum. Change in momentum. Very, very important point. Change in momentum. Okay, change in momentum represented by the symbol delta P. Delta P means variation, difference of momentum at two different instant. Okay, so at two different instant, we have to find out that change in momentum. Okay, here difference we can calculate. We have to calculate difference of that particular momentum. Okay, final momentum minus initial momentum. Final momentum minus initial momentum. So already I explained this point. Okay, difference of here. Here 1 kg meter per second. Here we have to consider 5 kg meter per second. 5 kg meter per second minus 1 kg meter per second is equal to how much? 4. 4 kg meter per second. Yes or no? So for addition or subtraction, we cannot change that unit. We cannot change that unit, but numerical value only changes. Yes or no? Here numerical value changes for difference. So here consider that symbol is minus symbol. 5 kg meter per second minus 1 kg meter per second, that is equal to 4 kg meter per second only. Here unit as it is, you have to write. Okay, so which operation, for which operation we have to apply this condition? For addition and subtraction. Okay, students, don't forget this point. For addition and subtraction, we cannot change that unit. 1 kg meter per second minus 5 kg meter per second minus 1 kg meter per second equal to 4 kg meter per second. Okay, so now we have to explain the derived physical quantity for change in momentum. Same only. Yes or no? So write here unit of change in momentum. 1 kg meter per second. 1 kg meter per second. Next, that is equal to 1 Newton second. It's very, very important point. So in before condition, we did not use that Newton. But for change in momentum, we can use that Newton second. Okay, Newton second. What is the reason? Here, Newton first law can explain without force. Newton first law can explain without force. Because of that reason, we don't use that Newton symbol. But Newton's second law can explain with the force. Due to that reason only, momentum changes. Momentum changes. That point we have to learn in 8th class. So no need to worry about that point. Okay, just note down these 2 points, very important points. Understood, students? Okay, so for change in momentum, we have to use that unit is 1 kg meter per second, that is equal to Newton second. So what is the reason? Means for change in momentum is possible due to the external force. But Newton first law can explain without force that body can maintain its constant velocity. Constant velocity. So that condition we can explain with these fundamental units. Okay, 1 kg meter per second is the derived unit of linear momentum. So 1 kg meter per second or 1 Newton second is the derived unit of change in momentum. Understood, students? Note down these derived units first. After that, we can go to another physical quantity. Okay, students, let us continue our next derived physical quantity. Next derived physical quantity. What is our next derived physical quantity? Work. Okay, next derived physical quantity, work. Work equal to force into displacement. Work equal to force into displacement. What is the SI unit of force? SI unit of force 1 kg meter per second square. 1 kg meter per second square. Just before I explain that derived of force. 1 kg meter per second square into displacement. Into displacement. 1 kg meter per second square into displacement, that is equal to 1 kg meter square per second square. 1 kg meter square per second square. Okay, so it is a general explanation of derived unit with the help of fundamental units. Okay, another formula. So another unit also is there for same work. What is that unit? Okay, so we have to consider that unit, its note point, very important. So in examination, we can get this formula. Note point 1 kg meter square per second square equal to 1 Newton into meter. SI unit of force. SI unit of force 1 Newton into SI unit of displacement meter. 1 Newton into meter, that is equal to 1 joule. That is equal to 1 joule. So joule is the scientist name. The honor of a scientist name, we have to given that unit for that work. Okay, SI unit of work 1 joule. SI unit of work 1 joule. 1 joule equal to 1 Newton into meter. 1 Newton meter equal to 1 kg meter square per second square. 1 kg meter square per second square. Okay, students, in examination, they will give that units. Multi-answer type question. Okay, multi-answer type questions means you have to choose more than one answer. So in examination, what is SI unit of work? What is SI unit of work? They given first option A, 1 kg meter square per second square. Okay, second option 1 Newton meter, 1 Newton into meter. Okay, so third option 1 joule. Fourth one none. Fourth one none. Now we have to say the answer. Option 1, option 2, option 3 are right answers. Okay, it is not a single answer type question, it is a multi-answer type question. They will give these options. Understood? What is the SI unit of work? Option A, 1 kg meter square per second square. Option B, 1 Newton meter. Option C, 1 joule. Option D, none. Okay, so we have to choose that right option for multi-answer type question. SI unit of work. Which option is correct? 1 kg meter square per second square is the correct option. Next, 1 Newton meter is also one correct option. Next, 1 joule is also one correct option, but none we don't choose. So it is a wrong option only. So answers A, B, C. We have to bubble these 3 circles. Okay, A bubble and B bubble and C bubble. Don't bubbling that fourth one. Okay, na? Have you identified that point? Okay, so like that they will ask in examination. Okay, students, note down this point. Next, another physical quantity. Next, another physical quantity, power. Power equal to work divided by time. Work divided by time. SI unit of work, we have to say, SI unit directly we have to consider that 1 joule per second. 1 joule per second is one SI unit of power or derived unit of power. 1 joule per second equal to 1 watt. Okay, so 1 watt equal to 1 joule per second. Generally, this name we have to watt. 1 watt equal to 1 joule per second. So 1 power equal to work by time. 1 SI unit of power is 1 joule per second. 1 joule per second is also called as 1 watt. Okay, 100 watts bulb, 200 watts bulb, 300 watts bulb. Generally, we have to call that point 100 watt. Okay, so 100 watts bulb, 100 watts bulb. Okay, 100 watts we have to consider. So is the derived unit of power, not 100 watt. Okay, so 1 watt equal to 1 joule per second. So power equal to work by time. Next, another point, energy. Another point, energy. Energy, how many types? Two types of energy is there. One is potential energy, P is equal to mgh. SI unit of energy. SI unit of energy is 1 joule. SI unit of energy is 1 joule. Okay, so now just identify unit of work and unit of joule is same. Don't forget this point. Unit of work, unit of energy is joule. Same units. Next, kinetic energy. Kinetic energy K equal to half mv square. Half mv square 1 joule. Okay, SI unit of kinetic energy is 1 joule. Your SI unit of work, SI unit of energy is same. In examination, which pair is having same units? Which pair is having the same units means energy and work. Energy and work is the correct answer. Okay, so we have to identify this condition. Very, very important condition. Okay, students, note down this point. Okay, enough this derived physical quantity and it's a derived units. Okay, students, so you have to open your material and read these points first. So what are the points I explained on the board? That points you can complete. The next one, this formulas also very, very important from 6th to 10th class. So all the formulas we can learn in further classes also. Okay, in 7th, 8th, 9th, and 10th also. Because of that reason, we have to learn these units and the formulas. So these formulas all are related to derived physical quantities. Don't forget this point, derived physical quantities and derived units. Fundamental physical quantities we cannot explain with the formula. So fundamental physical quantity only you can explaining with the symbols. Only you can explaining with the symbols, there is no formula. But these all are we can explaining with the formulas. Okay, formulas and derived units. Don't forget this point. This is a very, very important logical points. Tomorrow and next class. Next class, we have to continue that the supplementary physical quantities and the system of units. Then we can complete that. So synopsis 1 and synopsis 2. After that, we have to discuss two worksheets. Worksheet 1 and worksheet 2. So next we can conduct one small test on these two synopsis. Okay, students. So don't forget regularly you have to follow these points, then you can use it to get the knowledge in physics. Okay, so don't worry about these all points. So after further classes, we have to learn all physical quantity with detailed manner. Okay, students. Okay, bye.